Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on part 1 of a 4-part video series on algebraic functions for mathematics grade 10, and that is the straight line graph. On that note, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on this part 2 and more of this series and more videos we upload in the future. And if you have a question or would like to make a video request, please comment down below with the topic and grade you'd like me to cover, or alternatively send all that information to the contact details provided in the description box. Lastly, please don't forget to like this video and share it on all social media platforms so that the algorithm shows it to more and more people so your friends can get the help they need as well. Now back to the video. In detail, we're going to look at number 1, definitions and uses of functions. What are functions and how do we spot them? Number 2, we're going to look at different types of notations and how to use them right. Number 3, we're going to look at types of representations of functions and to help you notice and figure out that you're still dealing with the same function just on a different representation. Number 4, we're going to look at the dependent on independent variables. You need to know who's who in the zoo and how to spot the independent variables. Number 5, we're going to look at functions of the form y equals to x, which is the most basic standard format of a straight line graph. That basically is grade 9 revision. This is the straight line graph you plotted in grade 9. Number 5, we're going to look at functions of the form y equals to mx plus c, which is a more complicated form of y equals to x, right, of a straight line. However, this is the standard format we're going to be using until grade 12 and beyond. Number 7, we're going to look at characteristics, which is basically your domain, your range, your gradient, and the x and y intercepts. Number 8, we're going to look at examples on how to plot your straight line graphs using 2 different methods that you're going to see in a few moments. We have a lot to cover, so let's start. First, let's deal with the definition. What is a function? A function is a mathematical relationship between 2 variables where every input variable has one output variable. And uses are, for example, if you want to figure out what is the growth of a child and what is the, for example, what are the heights of people depending on their age. The relationship of the height of a person depending on their age. Now let's look at types of notations. When dealing with functions, we're going to use a couple of different notations. It's important for you to know who's who in the zoo and understand how each different notation works. And choose whichever one you feel like works best for you. However, in a situation where you are asked to present your answer in a particular notation, you also need to know how to work through all these types of notations. Let's start with the first one, set notation. This one basically works like this. It says x maps x is an element of real numbers such that, that's how we read it, such that your x is greater than 0. This is a set of all real numbers that are positive. Now, if you're not sure what your numbers look like, go through the video on the number system that I posted a few months ago. There you will be able to figure out what is a real number, what is an integer, what is a natural number, what is an imaginary number, what is a rational number. All those important details so that you understand how to work with your functions right. Number 2 says y maps y is an element of natural numbers. Remember, your natural numbers are numbers that you can use to count. If a baby can see it and they can count it, 1 cow, 20 cows. You cannot count negative cows. You cannot count 0 cows. There's no cows. Those are your natural numbers. That is a set of natural numbers between 3 and 5, including 5 but not including 3. Over here, your numbers do not include 0. So it's all the numbers greater than 0. Here it says z maps z is an element of integers such that z is less than or equal to 100, meaning that your 100 is included, but everything less than or equal to 100 is included in this set. Now let's look at the next notation. That is called the interval notation. Notice something that is important. This notation can only be used to represent an interval of real numbers, meaning that imaginary numbers do not apply here. If you're not sure what an imaginary number is, go through that video on the number system that I posted a few months ago. Now, you use brackets to indicate this type of notation, which is the interval notation. A round bracket means that that number is not included. For example, in this case, your set is a set of real numbers between 3 and 11, but not including 3 and 11. So anything between the two numbers, but not including the endpoints. Now, when you're including an endpoint, you have a square bracket to show that. For example, in this case, when you've got a square bracket in front of 1, that means 1 is included. You've got a round bracket in front of 9. After 9, that means your 9 is not included. So this is a set of real numbers between 1 and 9, including 1 but not including 9. Now notice something also that's very important. Whenever you're dealing with infinities, whether it's negative or positive infinity, your bracket will always be a round bracket. Reason being that you cannot pinpoint the number at infinity. It just goes on and on and on and on. So you put a round bracket where infinities are involved. Here, this is a set of all real numbers that are less than -2 and not including -2. That's how you read that. Now, the last notation we're going to look at is the function notation. Instead of writing your function as y equals to 2x plus 1, for example, we'll write it as f of x equals to 2x plus 1. That's how we say it out. F of x is equals to 2x plus 1. Now, you can use any number or any variable in your alphabet, any letter in the alphabet. You can use g of x, h of x. You can use this to denote different functions when working with a number of multiple functions in one set of x's. P of x or a of x or j of x or I of x or whatever you want to use. It doesn't have to be f. It's just that f is the one that we use to the most. So if you're comfortable with f, use f. If you're dealing with more than just one, use f and whichever other one you prefer. Now let's go to the next page. Now let's look at an example. Example 1 says, number 1, write the following insert notation. So you've got your numbers in interval notation and they want you to convert them to sort notation. On the second one, you've got them on set notation. They want you to convert back to interval notation. Let's start with example 1. Now I've duplicated all these questions here so that it's easy for us to answer them. All right, the first one goes, your set of real numbers between -infinity and 7. So these are numbers that are less than or equal to 7. So this is how you go. So x maps x. You can use another variable if you want. I just prefer x because it makes life easier that way. X maps x is an element of real numbers such that your comma is such that your x is less than or equal to 7. That's how you represent that insert notation. Number 2, this is between -13 and 4, including -13 but not including 4. So you go x maps x. X maps x is an element of real numbers such that your x is between 4 and not including 4 and -13 but including -13. Okay, let me fix this. Okay, let's start with -13. -13 less than or equals to x less than 4. Okay. All right, next one. These are numbers that are bigger than 35 and not including 35. So that's x maps x is an element of real numbers such that your x is greater than 35 and not including 35. So your x is greater than 35. Next one. This is between 3/4 and 21, including 3/4 but not 21. So we go x maps x is an element of real numbers such that your x is between 21, not including 21, and including 3/4. Next one, both negative half and half are included. So we go x maps x is an element of real numbers such that our x is between and including half, and on the other end including negative half. And that's how you write that. Last one, your number is between negative square root of 3 and infinity, meaning that all numbers greater than negative square root of 3, not including 8 because we have a round bracket. So this is how you represent it. X maps x is an element of real numbers such that your x is greater than minus square root of 3. And then the bracket. And that is how you change from the interval notation to set notation. Easy peasy so far. You shouldn't struggle with this now. All right, let's look at number 2. Example number 2 says write the following in interval notation. So we've got all these set notations to convert to interval notation, which should be very easy. Okay, let's blow this up so you can see what we're dealing with. Okay, now let's reduce. All right, so this is all numbers greater than, less than, or equal to 6. All right, so we're dealing with negative infinity, and then 6 is included, so we have a square bracket. All right, next one says x maps x is an element of real numbers such that x is greater than a fifth. All right, so that means a fifth is not included, so we have a round bracket there, and infinity on the other end, positive infinity. Next question, k maps k is an element of real numbers such that it's between negative 5 and 5, not including either end. So we've got round brackets, easy peasy here. Last one, z maps z is an element of real numbers such that your x is between 21 and 41, not including 41 but including 21. So we have a square bracket on 21, and then 41 has a round bracket. And that is how you change from set notation to interval notation. Easy peasy so far. Now let's look at the next question. Next question says complete the following tables and identify the function. Okay, here are the tables. That should be interesting. Okay, let's look at the pattern over here. You've got your numbers 1, 2, 6, right? And look at the y values. When x equals to 1, y equals to 5. When x equals to 2, y equals to 10. When x equals to 3, when x equals to 4, 20. Now, if you can see, we already have a pattern. These are multiples of 5. That's 5 times 1, 5 times 2. The next one should be 5 times 3, which is 15. And that's how you spot that pattern. Next one, 20. Next one should be 25 because 5 times 5 is 25. And the last one is 30 because 5 times 6 is 30. Next. Now, what type of a function is this? It's a straight line graph. It will look something like this. Don't worry if you can't figure it out right now. You're not supposed to yet. You will be able to, however, do all that. And it starts at 0, it connects at 0. Something like this. All right. It's a straight line graph with a positive gradient. Okay, next one. You've got 5s at the bottom. You can see the pattern is 5, 5, 5, 5, 5, 5, 5. So let's go there. 5. So whatever your value of x is, your y value is 5. All right. So that should be 2, and that is 5. Meaning that what type of pattern does it give us? It's a straight line graph, but with a gradient of 0. If you don't know what a gradient is here, don't worry. We will take a look at that. So that means that's your your y-axis, your x-axis. That means your graph goes something like this. It's a straight line graph that goes like this. Okay, and this value over here is 5. Y equals to 5. Alright, let's move on to the next thing. Types of representations of functions. You can represent functions in many different ways. The first way is your words. The relationship between two variables is such that one is always 5 less than the other. That's one way of saying the same function. Notice that this is exactly the same function on each representation. Okay, the mapping diagram, you've done with this mapping diagram in primary school, so you shouldn't struggle with this one. So you input numbers, you've got your input numbers, and you've got your function where the numbers are inputted, and then you've got your output. Now, how do we figure this one out? Let's say, for example, when you input -3 into the machine of x plus x minus 5, that's what happens. Your x becomes -3 minus 5, which gives us -3 minus 5. And we know that when we add these two together, they give us -8. That's how that function works. Now here's another representation. It's a table. That's another representation of a function. You've got your input values at the top, and then you've got your output variables at the top. All right. At the bottom, I mean. You can also use a set ordered number pairs. There, -3 goes with -8, 0 goes with -5, and 5 goes with 0. Can use an algebraic formula, which is what we're going to use a lot in this particular video. Here is an algebraic formula. F of x equals to x minus 5. It's still exactly the same function we're dealing with. Or you can use a graph. That is also a function. In fact, the name graph and function can be used interchangeably. That's why I said algebraic functions and specified it as the straight line graph in the description. And there is the function. You've got your ordered pairs, -3, -8, 0, -5, 5, 0. Those are the ordered pairs. That is the number of ways you can represent a function. Any of these ways is fine. Don't let that confuse you. You're dealing with exactly the same thing over here, just different representations. Now let's look at the dependent and independent variables. Who's who in the zoo? In functions, the x variable is known as the input or independent variable because its value can be chosen freely. The calculated y variable is known as the output or dependent variable because its value depends on the chosen input value. That's why your y is dependent on your x. So the independent variable is your x, that is your input. And that's how you figure out who's who in the variable department. Now let's look at example 2. Now we're starting. Let's plot functions of the form y equals to x. You probably have done this in grade 9. So it shouldn't be new for you. For those who haven't had the opportunity to do this in grade 9, this is a perfect way to refresh your memory and to make sure that you catch up with the rest of the people. All right, so you've got a function, and the question says complete the table f of x equals to x and plot the points on a set of x's. Okay, we're going to plot the points on the end of set. So you've got your function, right? Your function notation, and here we've got the table notation. Now let's complete this table. All right, when x equals to -1, what is our y? When x equals to -1, so we're dealing with f of -1 equals to -1 because your function is x, right? So you substitute that which is equals to -1. At 0, f of 0 is equals to 0, which is equals to 0. At 1, f of 1 equals to 1, which is equals to 1. At 2, f of 2 equals to 2, which is equals to 2. So here, let's now complete the table. So we've got -1 here, we've got 0 here, we've got 1 over here, and we've got 2 over here. That's how you complete the table. Easy peasy. Now let's remove this so we don't get ourselves confused. All right, now let's plot the graph. Join the points with a straight line. Let's plot the points first. Notice that for each x value, you've got the same y value. Okay, let's plot this on a set of x's. Let's plot this. Okay, we're going to plot the red graph now. Okay, but before we do that, so remember when x equals to 0, y equals to 0 as well. So that's the point, 0, 0. When x equals to 1, y equals to 1. When x equals to 1, y equals to 1. So that's the point there. That's where they meet. When x equals to 2, y equals to 2. So that's the point over there. That's the point. On the left hand side, when x equals to -1, y is also equals to -1. That's the point. -2 goes with -2, and that's where the point lies. -3 goes with -3. Now let's join all these points in a straight line. Okay, let's join them in a line. That's the line. Now let's make this a little thicker. All right, now let's see what the graph calculator calculated for us. There, exactly like the graph calculator would do. Now you were asked a couple of other questions. Let's go to the questions. You're supposed to determine the domain and range. What is the domain? The domain is all elements of real numbers. There is no point on the x-axis where your graph is not defined. And the range, same story for the range. The range is also all real numbers. Okay, that's the domain and the range. All right, what about which line is f symmetrical? F is symmetrical about the line y equals to x. Using the graph, determine the value for x when x equals to 4. When f of x equals, when y equals to 4. Okay, what happens when y equals to 4? When y equals to 4, we have what? There. When y equals to 4, x equals to 4. And that's how you answer that question there. There is the point. That is the point. There is the point. Where does the graph cut the axis? The graph cuts the axis at 0 for both the x-axis and y-axis. They are all cut at 0. And that's how you read that graph. Now let's look at functions of the form y equals to mx+c, which is a little more complicated, but it's a standard format of the straight line graph that you're going to use all the way to metric and beyond. So get this right. This is the standard format that you need to get in your head and memorize if you have to. But no need to memorize because you're going to be seeing this all the time from now onwards. All right, what happens? Let's look at the effect of C. All right. The effect of C is such that, let's look at y equals to x. Y equals to x is the red graph. Y equals to x is the red graph. The red graph cuts the axis at 0, 0. Cuts your y-axis as 0. C is your y-intercept. C is your y-intercept. So when C is 0, you got y equals to x, right? Your C is 0. So it cuts the graph at 0. Now what happens when your c is equals to 1? Notice that your graph is now shifted 1 unit up. In other words, it cuts your y-axis at 1. Same thing when your c is equals to 2. You got the green graph. It cuts the y-axis at the point 2. That is point 2. What happens when your c is negative? That means you shift the graph down. Y equals to x minus 1, that is the purple graph, was shifted 1 unit down. So here, your x-intercept is at negative 1. Same with x, when your c equals to negative 2, y equals to x minus 2, you've shifted your graph. Which graph? The red graph. You shifted the red graph, 2 units down. And that is the effect of c. You move the graph up and down depending on whether it is positive or negative. Now let's look at the effect of m, your gradient. Your m is your gradient. For y equals to mx plus c, m denotes your gradient. Okay, let's start with the simple basic one. Y equals to x. Your gradient is 1 because the coefficient of x is 1. So that means your m is equals to 1. What happens when your m is equals to 1? Notice that our intercepts are all at 0. So the only thing we're looking at is what the gradient does here. So you've got your line right in the middle, your standard basic line. Now what happens when your y equals to minus x? In other words, your m is a negative 1. You get the same graph, which is blue, but it slopes to the other side. It slopes to the left. So your red graph with a positive gradient slopes to the right. All those with positive gradient will slope to the right. All those with negative gradient will slope to the left. Now what happens when your y is 2x? In other words, your m is multiplied by 2. When your gradient is 2, what happens is that you get a green graph, which basically gives you a steeper graph. You reach milestones faster, so it's going to be steeper because your gradient is bigger. What happens when it goes to negative 2x? It's going to slope to the left, but still steeper than the one of y equals to negative x. And that is how m affects the graph. Now let's look at the characteristics of this straight line graph. Basically, your domain and range are easy. X is an element of all real numbers. F of x, which is your y, is also an element of all real numbers. Easy peasy. There is no place where any of the domain or range is undefined. Now let's look at the gradient. When you've got your equation y equals to mx plus c, your gradient is m. Your gradient is m. Whatever your m is, that is what your gradient is. That is the change in y over change in x. It is equals to the change in y over change in x. Don't worry about that if you don't know. I'm going to show you exactly how we figure that one out. Now, what about the y-intercept? The y-intercept is simply your c. Or simply make your x equals to 0 and solve. You will find what the y-intercept is. To find the x-intercept, you make y 0, and then the x-intercept will get to you when you solve that equation. Now let's look at another example. Example 3 goes, sketch the graph of g of x equals to x minus 1 using the dual-intercept method. Notice that this one has got your c equals to negative 1, meaning it will be shifted. But what direction? Is it going to be up or is it going to be down? Remember, when your shift is up, your c is positive. But when your shift is down, your c is negative. Not sure what this is going to look like yet? No problem. Let's figure out what the intercepts are. Okay, now let's find the y-intercept first. Okay, let's change. Let's find the y-intercept. Okay, to find the y-intercept, you make x 0. Let's find the y-intercept. Make x 0. Okay, so we go g of 0 equals to 0 minus 1. We substitute 0 for. That gives us g of 0 equals to -1, meaning that the y-intercept has got the coordinates 0, -1. Now let's find the x-intercept. To find the x-intercept, you make y0. Make y0. Make y0. Alright, so we go 0 is equals to x minus 1, and we solve. Take everything that's not x to the left hand side, so that becomes 1 equals to x. Therefore, the x-intercept is the point 1, 0. Now let's plot these points on the graph, on a Cartesian plane. But before we do that, let's plot the normal y equals to x. But before we do that, okay, let's plot the points. The points are, okay, your y equals to -1, y equals to -1, and x equals to 1. Y equals to -1, there is the -1, and x equals to 1, 0. All right, now let's plot the normal y equals to x graph for comparison purposes. This one goes like this: 0, 0, 1, 1, 2, 2, -1, -1, -2, -2, -3, -3. Okay, now let's join all these points. Okay, let's join all these points in a straight line. There is the straight line. Okay, there is the straight line. Now, we've joined. You've got, on the blue graph, you've got your x-intercept at 1, 0, and your y-intercept at 0, -1. So you join the two. Let's join the two. Let's make it blue. Let's make it blue because it's supposed to be blue. That's how you draw that one. Now let's see what the graph calculator did. It did exactly the same thing. There is your blue graph, y equals to x minus 1. Shifted 1 unit down. Now for example 4, sketch the graph of p of x equals to 1/2 x minus 3 using the gradient-intercept method. You're no longer using the intercept method, which is finding the x-intercept and the y-intercept. We're using the gradient-intercept method. How does the gradient-intercept method work? Here is how it works. Let's change the color first. Here is how the gradient-intercept method works. Let's look at the gradient first. Our gradient, that is equals to m. M equals to 1/2. That means for every 1 you go up, you must go 2 to the right. And I will show you how that works out in a set of x's. 1 up, 2 right. For every 1 up, you go 2 right. All right, now let's look at the y-intercept. The other intercept will be the y-intercept. To find the y-intercept, as you should know by now, to find intercept, y-intercept, make x 0. Alright. Therefore, p of 0 equals to half times 0 minus 3, which is equals to 0 minus 3. Meaning that the y-intercept is this point, 0, negative 3. So what we do is we indicate the y-intercept on the set of x's. Let's go. That's negative 3. 0, negative 3. 0, negative 3. There is the point. Let's indicate the point. Alright, 0, negative 3. Let's leave it here for now. Now let's plot the normal y equals to x graph for comparison purposes. Okay, let's plot 0, 0, 1, 1, 2, 2, 3, 3, negative 1, negative 2, negative 2, negative 2, negative 3, negative 3. Okay, let's go to the last one. Now let's join this together. The standard graph just helps us to keep things in perspective. You don't have to draw the standard graph all the time. It just helps to keep everything in perspective. And there is the red graph, the standard y equals to mx, y equals to x. Now, let's figure out how we now draw this one using the gradient-intercept method. We started at our y-intercept. The y-intercept says, the gradient says we must go 1 up and then 2 to the right. And that's where, okay, now let's change the color. One up again, 2 right. There we go. 1 up, 2 right, 1, 2. And that's where it lands us on 6. Now on the left hand side we go 1 down, 2 left. So that's where we land. 1 down, 2 left. Again 1 down, 2 left. Again 1 down, 2 left. 1, 2. 1 down, 2 left. And so on and so on and so forth. 1 down, 2 left, 1, 2. And now let's join this point. Let's join this point. Okay, let's join this point. This should be our blue graph. Yes, let's change the color to blue. And there, that is the graph of y equals to x, and that is the graph of y equals to half x minus 3. Now let's see what the graph calculator drew for us. Perfect. These two meet at the point negative 6, 6. That is the point where they meet. This is the point where they meet. Negative 6, 6. Okay, let me make it bigger so you can see. This is the point where they meet. And that's exactly the point where they met on our graph as well. There is the point where they met. Negative 6, 6. So this is an accurate drawing. And the graph calculator agrees with us. Now let's go to example number 5. Now let's use all the knowledge that we now have to figure out which line belongs to which equation. Alright, we've got two graphs that have got negative gradients. That's this graph and this graph. Let me see. F and E have got negative gradients. F has got an intercept at 0. So F is negative there but with 0. So that is the graph. That is graph F. So that's number F. Let's see if we can connect this. So this is how we connect. This is number F, small f. Let me decrease. That is small f. This one is small f. Okay, the other one with a negative gradient is this one, E. And here is the one with a negative gradient. But as a, okay, negative gradient with 0, no, sorry, please forgive me, I made a mistake here. Let's look at the graph here. Let's look at this graph. It has a gradient, it has an x-intercept of 0, so it meets the x-intercepted y. Then when you take it to the left, one left, and you go 1, 2, 3, it matches with this graph. It matches with D. So F matches with D. This is D. We've got the other negative graph. It has a y-intercept of 6. Y-intercept of 6. Let's see the y-intercept of 6. There it is. Y-intercept of 6. No, y-intercept of 5, sorry. Y-intercept of 5. And the gradient is -2. It's negative. The gradient is negative. Yes, so that's number A. E goes with number A. It goes with number A. We're done with the negative gradient graphs. And then you've got the one that is just no gradient, number D, and it has your y equals to 1. There, that's number E. So D goes with number E. Okay, let's see. We've got 2, 3 that have got positive gradient. Number B has an x-intercept of 3, y-intercept of -6, y-intercept of -6. There's the y-intercept of -6. And it's a positive graph. So you go 2 up with 1 to the right. 2 up, 1 to the right. Yes, it does match. So number B matches with C. Number B matches with letter C. Let's see what the other ones. Okay, so we left with C and A. Alright, A has got a y-intercept of 5. And let's see what the gradient looks like. You go 1 down, Okay, from here, 1 2 1 2 1 1 1 1 1 1. So the gradient should be 1x. Okay, the x-intercept is 5. There, it's number B. Number B goes with A. Number B goes with A. Now let's see what the other one goes with. Number C is your y-intercept at 0, but let's look at the gradient. 1 2 3 4 1. So it's 1 and 4. So that should be 1 over 4. 1 over 4, let's see. 1 over 4. Okay, the x-intercept is 0. I mean, the y-intercept is 0. The y-intercept is 0. Yeah. Number C goes with, this should be positive. Okay, this is positive half x. So that goes with number F. C goes with number F. And that's how you figure out this. That's how you match graphs to their equations. Now let's look at the next example. It says state whether the following are true or not. The gradient of 2y equals to 3x minus 1 is 3. No, that is false. It's not true. This is false. What is the true one? If you were to put this in standard format, you would have divide both sides by 2. So that will be y equals to, that will be y equals to 3 over 2 x minus 1 over 2. So the gradient should be 3 over 2. So this is false. Okay, the gradient is 3 over 2. Alright, number B, the y-intercept of y equals to x plus 4 is 4. That is correct. It's true. This is true. The gradient of 2 minus y equals to 2x minus 1 is negative 2. Let's see what happens when you rearrange the equation. Alright, so take everything to the left hand side. Okay, so take everything to the right hand side. So you've got negative y minus y equals to 2x minus 1 minus 2. Therefore, minus y equals to 2x minus 3. Divide both sides by negative 1. The standard format of the equation is minus 1 negative 2x plus 3. Yes, so that is correct. It is true. If you put that in standard format, you will see the answer will pop right at you. Next question, the gradient of y equals to 1 over 2 x minus 1 is negative 1. That's false. That is the y-intercept. The gradient is 1 over 2. There is the gradient. The y-intercept of 2y equals to 3x minus 66. No, false. It's negative 6. That's how you answer that question. Write the following in standard form. Y equals to mx plus c. So what you do is you take everything that's not y to the right hand side. So that leaves you with 2y. That's 2y equals to negative 3x plus 1. Now divide both sides by 2. That leaves with minus 3 over 2 x plus 1 over 2. And that's therefore y equals to, therefore y equals to minus 3 over 2 x plus 1 over 2. That's the standard format of the graph. Next question, which is the last question. Determine the x-intercept and y-intercept of the following equations. To find the y-intercept, make x 0. To find the x-intercept, make y 0. Okay. X-intercept y 0. Therefore, 0 equals to x minus 1. Take everything that is not x to the left hand side. That's 1 equals to x. Therefore, x-intercept is 1, 0. That's the x-intercept. Y-intercept, you make x 0. Make x 0. You go y equals to 0 minus 1, which is equals to negative 1. Which is equals to negative 1. Therefore, the y-intercept is 0, negative 1. That's the point there. And we're done with this one. Number 2, x plus 2. Okay, to find the x-intercept, you make y 0. So 0 equals to 0 equals to x plus 2. Take everything that's not x to the left hand side. Negative 2 equals to x. Therefore, the point is negative 2, 0. For the y-intercept, make x 0. Therefore, y equals to 0 plus 2, which is equals to 2. Therefore, the point is 0, 2. Last but not least, y equals to x minus 3. X-intercept, make y 0. So we go, therefore, 0 equals to x minus 3. Therefore, take everything that's not x to the right and left hand side. 3 equals to x, meaning that the point is 3, 0. The y-intercept, make x 0. Therefore, y equals to 0 minus 3, which is equals to negative 3. Therefore, the point there is 0, negative 3. And with that, we've come to the end of this video. Thank you very much for watching. See you on part 2 of this series. Bye.